Assalamualaikum warahmatullahi wabarakatuh. My name is Zatie Nurdiana binti ZAHRINNUDDIN. My matrix number is 2022-75815. So for today, I'm going to explain and demonstrate on my individual assignment using MAT491 2022.
Section A. Plot the following surface using either three options of the plotting: plot 3D, implicit plot 3D, or parametric plot. Name the surface and we will have to experiment with the limit of the variables. So for section A, I'm choosing question B and question C. Question B, the equation given is x squared plus y squared plus z squared equals to 4. Now let's see how the mapper comments work. Okay, so I'm starting with open bracket plots, close bracket, and semicolon. Enter. The output is as follows. And then next, I'm insert the equation x squared plus y squared plus z squared equals to 4 and then semicolon. Okay, so for this question, I'm using the implicit plot 3D since it has three variables x, y, and z. Okay, so the mapper command would be implicit plot 3D, open bracket, f, the function we wrote just now, x, for the limit, I put it x -4 until 4, y -4 until 4, z -4 until 4, and the color is blue. The color could be anything if you want, but I choose it to be blue. So then enter. This is the output of the question. Okay, now let's take a look on another example. If I change the limit, okay, so using the same function, implicit plot 3D, f, the limit I change it into -2 until 2, y -2 until 2, z -2 until 2, and the color I change to red. Semicolon, enter. So this is how it looks like. So as you can see, both of the output turns out similar, and the name of the surface is sphere. Next is question C. The equation given is x squared plus y squared equals to 4. Okay, so I start with the common with open bracket plots, close bracket, semicolon, and then the function, I write it x squared plus y squared equals to 4, not to forget to put an f in front so that we can call back the function on the next command. Okay, so for this equation, I still use the implicit plot 3D, even though it only have two variables here, x and y. But since z could be anything limit, so I still use implicit plot. Okay, so for the limit, x I use -4 until 4, y -4 until 4, and z -4 until 4. So the color I choose purple. Okay, let's look how it turns out. Okay, this is the output of the equation. Okay, let's try another example with using different limits. Okay, implicit plot 3D, f, x -4. Okay, so I change the limits for y-axis and z-axis. Okay, I change it to negative until 2, and for z-axis, I change it 0 until 1. So let's see what the output looks like. Okay, so this is how it looks. Since I changed the y and z axis limit, the surface also changed. Okay, as we look into the output, it looks like it's been cut. Okay, so we compared from the output 1 and then the second output, we can conclude that this is a cylinder surface. Section B. Okay, I choose question 1. Plot the solid that lies between the cone z equals to square root x squared plus y squared and the plane z equals to 4. Okay, so first of all, I wrote out the function from the question and also z equals to 4. Okay, so as the question mentioned cone for this equation, so using the function of cones, colon equals to plot 3D, open bracket, square bracket, rho theta pi over 4, square bracket, and then rho equals to 0 until 4 secant pi over 4, theta equals to -5 until 5, and the chords equal to spherical. Okay, now enter. This is the cone surface. Okay, the next for planes, using the same plot 3D, for secant phi theta, and then theta equals to -5 until pi, phi equals to 0 until pi over 4, and the chord is also spherical. Okay, now let's see how it turns out. Okay, so this is for planes. Now, we need to combine the first output and then the second output. Okay, the common plots of a square bracket display, square bracket, open bracket, square bracket, the cones and planes with the function we wrote just now. Okay, and then viewpoint equal to circle left and close bracket. So, this is how it looks like. As you can see, the planes has become the base of the code. Now for question 2, plot the solid that lies above the cone z equals to square root x squared plus y squared and below the sphere z equal to x squared plus y squared plus z squared. First, you insert the function square root x squared plus y squared. Okay, the output is still the same, and for function z equal to x squared plus y squared plus z squared. Okay, and then the common for cone equals to plot 3D open bracket square bracket rho theta pi over 4 close square bracket rho equal to 0 until 4 secant pi over 4 theta equals to negative pi until pi cos equals to spherical. Okay, rho is the distance from point to origin, theta is the longitudinal angle, and the reason for pi over 4 here is because, as we know, for spherical cone the phi is equal to pi over 4. Okay, so now how it looks like for this comment. So this is the cone. Next, the common for sphere equals to plot 3D for theta equal to 0 until 2 pi and phi equal to 0 until pi and the chords equal to spherical. Okay, so the output looks like this. Okay, so this is the sphere. Now, we have to combine both of these surface so that we can come up with a conclusion. Okay, so combine both of these. The common would be plots square bracket display square bracket open bracket square bracket cone and sphere, the function we wrote just now, so we just have to call it back. Viewpoint equal to circle left close bracket and semicolon. So this is how it turns out like.
I think that's all from me. Thank you for watching.